Imagine a world where security vulnerabilities fix themselves. That's what Code Guardian does, an autonomous AI agent that detects, understands, and remediates code issues without human intervention. We built Code Guardian because developers spend over 15 hours each week fixing security issues, delaying innovation. With 60% of breaches coming from known flaws, the process clearly needs automation. Code Guardian runs entirely on AWS, powered by Bedrock's Agent Core for autonomous orchestration and Nova Light as the LLM. The agent thinks and acts on its own, scanning, reasoning, and fixing code using a modular toolset. This diagram illustrates the architecture of Code Guardian, our autonomous code remediation agent. The process begins on the left when a user requests an analysis of a code repository. This request goes to the Code Guardian agent, the core of which is the LLM core powered by Amazon Bedrock. Inside the agent, the reasoning engine makes decisions about how to proceed. Based on the request and its internal state, the reasoning engine interacts with the tool orchestrator, which is managed by Bedrock Agent Core. Agent Core contains the tool selection logic that determines which specific tool is needed for the current step. Agent Core then directs the tool executor to run the selected tool. The tool executor acts as the bridge between the agent's decisions and the actual execution of tasks. We have four primary tools available. The security scanner, integrated with Bandit, identifies potential issues. The file reader fetches source code from the target repository to provide context. The code analyzer, using AST parsing, helps the agent understand code structure. And the syntax validator checks the correctness of proposed code fixes. These tools interact with data sources, primarily the target repository's source code and potentially external vulnerability databases, like CWE standards for context. The results from the tool executor are sent back to the tool orchestrator, Agent Core, which then feeds these execution results back to the reasoning engine in the main agent. The agent iterates through this loop, reasoning, selecting a tool, executing it, and analyzing results multiple times. Finally, once the analysis is complete, the Code Guardian agent generates three key outputs shown on the top right: an analysis report summarizing the findings, proposed code fixes for the identified issues, and the reasoning chain, which provides a transparent log of the agent's decision-making process and tool usage throughout the analysis. This architecture allows Code Guardian to autonomously analyze code, understand context, generate solutions, and validate its own work, all orchestrated through Amazon Bedrock. Here's the Code Guardian GitHub repository. This is where you can find all the source code for the agent, including the agent logic in the SRC directory, the integration with tools like Bandit, and the Bedrock client. The repository also contains the project documentation in the read.md, setup instructions, the requirements.txt file for dependencies, and a test directory with our unit and integration tests. We've also included a sample vulnerable Flask app used for demonstration and testing. This is the Code Guardian live demo interface, hosted directly from AWS S3. At the top, the user can select a sample repository to analyze. In this case, we've chosen a vulnerable Flask application. Immediately, the status indicator updates, and the agent activity log appears below. This log provides a real-time stream of the agent's reasoning process, showing which tools it decides to use, like reading files or analyzing code context, step by step as it interacts with the backend Bedrock agent. Once the analysis is complete, the analysis results section is displayed. We get key statistics like the total number of issues found, how many tools the agent autonomously called, and how many fixes were generated. Below the stats, we see the detailed vulnerability cards. Each card shows the issue description and its severity, the exact file and line number, the relevant CWE identifier. Crucially, it shows the original before code snippet, identified as problematic, and the after code snippet, which is the agent's recommended fix, generated and validated autonomously. Finally, there's a snippet explaining the agent's reasoning for this specific recommendation, and handy copy buttons for the code. This interface provides full transparency into the agent's autonomous workflow, from initial request to final, actionable code remediation. This concludes video demo of the project for the AWS AI Agent Global Hackathon. Thanks for watching.